So with absolute time involves a number, absolute time or measured time. So we're only going to look at three different techniques in this course that will give you an absolute date or an absolute time. One is tree rings, one is glacial varves, and the other is radioactive dating. Two of the topics or two of the techniques are relatively small. One of the techniques, radioactive dating, is going to be much larger, and it's going to take us maybe close to a week of class time. With tree rings, otherwise called growth rings, one ring is equal to 1 year. Now, in places where there's strong seasonal contrast, like Newfoundland, so in Newfoundland we have a distinctive spring-summer and a distinctive fall-winter, a tree will add one new growth ring each year. And typically, though, within that one ring, it's almost kind of like two sub-rings. You get like a whiter type color and a darker type color. And that light dark represents one ring, which is 1 year. So if you were to look at the diagram over on the right side, on the bottom, you would not count the center dot, but you would go light dark 1, light dark 2, light dark 3, light dark 4, light dark 5, light dark 6, light dark 7. So it's close on 7 years old because, of course, you don't count the bark. For glacial varves, typically you get glacial varves in high altitude areas or high latitude areas, basically glacial locations. And you also have to have strong seasonal contrast as well. So just to make it clear what a varve is a pair of sedimentary layers that gets deposited over the course of one single year at the bottom of a glacial lake. Now, in the spring and summer, there's a lot of ice and snow that melts, so you get a lot of meltwater, and at that time you get a lot of sediments being moved, mostly coarse sediments, and those sediments are typically lighter in color. Now, in the fall and the winter, the glacial lake and the different streams and rivers that would go into that lake probably freezes over, so there's less energy for sediment to get transferred. So the only sediment that typically gets transferred is fine-grained sediment, mostly like mud. And also it's important that I point out that at that time of year you get a lot of plankton that dies in the water and settles out as well, and that typically makes the layers darker in color. So typically what you do is you count the pairs of coarse dark layers or fine light layers. So basically you can match it up by texture by saying coarse and fine, or you can match it up with color in saying light and dark. However, you have to have those two sedimentary layers to make up one varve, which is equal to. So in the picture to the right, it's tough to actually count how many years. You'd have to be able to count how many light darks. So what I will do instead is I'll just give you an example. So say if we did count it and we had 308 sedimentary layers. Well, obviously in 1 year there's one varve, which is 2 layers. So you'd have to take your total number of layers, which is 308, and you would have to divide by 2. That would give you 154 varves, which means 154 years of sediment deposition. So don't forget that one varve is equal to 2 layers. The other scenario that you could get, even as a public exam question, is they could say 60 varves. How many sedimentary layers would you expect? So that would be double. And the last topic is radioactive dating, and I'll cover that in the next video.